We've looked at many different techniques of integration, but what do we do when we are asked to integrate a problem like this? U substitution does us no good because we just don't have du. But what we do have is that we have a product of two functions. We have x cubed multiplied by e to the 3x. Well, we have a product rule for differentiation, but do we have a product rule for integration? Let's look. We're going to be looking at the technique of integration called integration by parts. It really is the product rule for integration. So let's review our product rule from Calculus 1. You were given a function that really was the product of two functions of x, and you learned to take the derivative by saying, okay, f of x, or the first, times the derivative of the second, plus the second times the derivative of the first. Many of you learned it in terms of f and g, others learned it in terms of u's and v's. We're going to take a minute and rewrite this product rule in terms of the variables u and v. So we have the derivative with respect to x of f of x, and I'm going to call that u, times g of x, and I'm going to call that v. So that now becomes f of x times the derivative of g of x plus g of x, or v, times the derivative of f of x. Now that looks kind of ugly, but bear with me. So you learned derivatives, and then you learned antiderivatives, which we called integrals. And you learned that those really are inverse operations of one another. So since we're trying to learn a technique of integration, let's take the integral of both sides of this equation. So I'd have the integral of the derivative with respect to x would equal to the integral of the right-hand side of that equation. So all I've done is I've taken the integral of both sides of that equation. We also learned that since we have addition, I really can rewrite that as two separate integrals. So again, we'd have the derivative with respect to x, and this would equal to the integral of u times dv plus the integral of v times du. Now I know that looks kind of strange, but again, we're trying to derive a formula. Let's rearrange, meaning what I'm going to do next is I'm actually going to subtract this from both sides of the equation. So I'd have the integral minus this integral is going to equal to that. And you're going, that just does not look helpful. Well, it will. Okay, let's go back and see what that is. When we integrate a derivative, what do we get back? What we started out with. So this really becomes just u times v. So we have, from here, we have u times v minus the integral of v du is going to equal to the integral of u times dv. And you're going, that just does not look helpful. Well, believe it or not, that is our integration by parts formula, just reading it the other way around. I'm going to start with here, the integral of u times dv, and listen to that, times, that's actually a product. U times dv is going to equal to u times v minus the integral of v du. Now what's strange about this is that I'm going to be integrating something, and yet I'm going to get back an integral. The idea is that this is something we don't know how to integrate with our basic integration techniques, whether it be U substitution or some of the other formulas we've memorized. But as we rearrange, This integral that we get back, that should hopefully be an integral that I can easily integrate.